Okay, so we're looking at the bumper switch exercise, and I'm going to go ahead and do the example. For this program, I'm going to go ahead and write the code in RobotC for waiting for the bumper switch to be bumped before the right motor turns on at half power for 5 seconds and then stops. So I'm going to go ahead and copy in my project description here, and I'm going to go to RobotC. I've got RobotC open. The first thing I'm always going to do when I'm starting a new program is I'm going to open up a sample program. I'm going to go down to the Project Lead the Way folder and open up the Project Lead the Way template. I'm going to go ahead and I'm just going to put my task description in here from the example. I would fill in the project title. This would be, let me see, bumper switch exercise example. So bumper switch example. Alright, team members, fill that section in, the date, fill that in, and then your section or your class period. For the pseudocode, I'm going to go ahead and take my description. What we're going to be doing in this program, the first step is I'm waiting for the bumper switch to be pressed. Okay, that's my first step. My second step of the pseudocode is going to be the right motor turns on at half power, and my next step of my code, of my pseudocode, is going to be we're going to wait for 5 seconds, and then lastly it says and then it stops. So the right motor turns off or stops would be the last step in my pseudocode. Now that I have my pseudocode, I can go ahead and I can convert this now into code. Anytime I write code, it needs to be inside of the curly brackets of task main. Task main identifies the start of your program. So I'm going to go ahead and look from my look under natural language for my functions. Okay. And the first one that we're going to be using is the waiting for the bumper switch to be pressed. This is one of our commands that ends up being under the until. All right. Under the until, I've got until bump, and if I read the description, it says the robot does what it is doing until the touch sensor is pressed in and then released out. So in this case, the sensor would have to actually be pressed down and then released before the next command would be processed. If I look at until touch, it says the robot does what it is doing until the touch sensor is pressed in. Okay, so the difference with that is it's waiting until it gets pressed in. Until bump, it has to be pressed in and then released out. So that is an important difference. So I'm going to use the until touch command. Alright, so until touch. Now for my sensor port, I have not set up my sensors and my motors yet, so I need to actually go back and do that. So I'm going to go up to Robot, and I'm going to do my motor and sensor setup. Okay. Now in my program, I've got a bumper switch, which is a digital sensor. It's either a 1 or a 0. It's either pressed or not pressed. And I'm going to name it. I'm going to name this one bump switch, and I'll capitalize the S since it's a second word. The type of sensor will be a touch sensor. This one is going to be wired into my digital 1 port. Alright, and I also have a motor. Okay, so I can select a port for my motor. Let's go ahead and do port 2, because in my test bed my right motor was in port 2 before. So right motor, and I'll select my type of motor, which is most likely the VEX 279 motor, but we do have a few 393 motors, so just make sure you check on your motor to make sure you got the right one. And I'll apply and hit OK, and now I can go ahead and replace my sensor port. I need to tell the program where the sensor is wired into, what port it's wired into. In my sensor setup, I made a name for it, which was the bumper, or the bump switch. Okay. If I don't remember what it was called, I can look up at the top here and I can see bump switch was the naming convention that I used. And I am now done with the first line of code. I'm going to make a comment so I know what this was. Wait for bumper switch to be pressed. Alright, so I'm making comments so I can understand this code better, and if anyone else is looking at it, they could read and follow along with it. Next, I want my right motor to turn on at half power, so I'm going to go to my movement commands, start motor, I'll drag that in place. Under motor port, I'm going to replace that with the name of my motor, which was right motor. Okay, for the speed, half speed, I can go to start motor, I can see my range of values is -127 to 127. If 127 is full speed, and half speed is going to end up being half of 127, which ends up being just about 63. Okay, I don't want any decimals. I'll make a comment for what this line of code does. This is right motor on at half speed. Alright, and I can go into my next line of code. Now I want to wait for 5 seconds. So I go to my wait commands. I'll grab my wait, drop it in place. My wait time, I'm going to replace that with the number of seconds. Alright, so 5 seconds. I'll make a comment over here. This is wait 5 seconds. And then lastly, my right motor turns off. So I will go ahead to movement command, stop motor. I'll drag that in there, and I'll replace my motor port with the name of my motor, right motor. Alright, and I'll make one last comment. Right motor stops. Okay. Alright, so now at this point I am ready to compile my code, and I can do that before I actually get my test bed. I'll go ahead and compile, make sure I don't have any problems. I need to save. Alright, I'll save this. Ooh, it doesn't like where I saved it. So I'll have to save this to my H drive. Alright, for this example I'll just save it to my desktop real quick, but you should save to your H drive. And now I will compile a program. And I got no errors down here, so my program is good to go. So at this point I can connect it up to my test bed with a USB cable. I can power it on. I can go ahead and compile and download the program to the VEX Cortex, and then I can just start my program, and I am good to go. So that is the bumper switch example. Alright, good luck with the first bumper switch problem. So now you, on your own, you're going to be completing individually this next example. Alright.